student down here. Okay.
Need my backpack extra.
Any specific questions from like 4.2 or 4.1?
4.2 is pretty.
I like to hear that. Any other comments or suggestions about 4.2 or 4.1? I like it. No, it's cool. Let's do a little review here then. What we've learned so far about these number systems. And the interesting thing about Math 120 is not everybody has to do, for example, this specific chapter. There are certain chapters you must do, and then I have some free reign as to what I want to add. But to me, this chapter is actually at the heart of what 120 is all about. It's taking a step outside of the math you're used to and showing you all the other things that math could be. And this, to me, is the most obvious way to do that. How could the entire math system we use have been different, right? So for some of you guys, you don't even realize until you see this that there were all these other ways to do this. They weren't handed down to us by these aliens and they said, you will use this or we'll come back and eat you. No. These are things that we've decided as a civilization that we would use, right? So what we've seen so far are things called place value or positional system. Can somebody give me an example of somebody that uses a place value or positional system?
Decimal, tens, hundreds.
Okay, so then who uses it?
We do.
We do. This is the type that we use. Yeah, Hindu, Arabic. Those are the numerals really, but we use the positional system, the place value system. Every place has a value, right? Who else uses this type of thing?
The Roman.
Careful, not the Romans.
Mayans.
Well, the Mayans, yes, Mayans
Babylonians.
and Babylonians. So, one key thing is, you can't tell me the Romans had, like if they put an M in a certain place, it means something else. What does M mean?
11.
100.
1,000, right? And X means 10. It doesn't matter where I put it. Now what matters is if I put a smaller in front, but that's a little rule they added to their system. They don't have a place value system, right? So for us, the reason ours is a place value system is 4 doesn't mean the same thing all the time. Here it's 4 tenths, right? Here it's 4 tenths. So the numeral means the same thing, 4 of something, but the place it's in. What about Babylonians? What place do they have? What base?
60.
60. So this place value system is related to the base. They've got to have some kind of a base, so they tell me what their places mean. The Mayans, of course, are the ones that kind of threw us a curveball.
Persisting.
They basically have a base 20, except for the one place where they forced 360 to show up, right? But there's still a place value system. If I put a blueberry by itself, I would think that meant 1. Now, if I mean that to be in the next place up, I better put a 0 down here. Now, this would be 120 and a 0. That's how I could write the number 20, right? Are you guys with me? Mm-hmm. So blueberry by itself, it means 1 something, but where it is changes what it is, right? 1 what? 120 in this case. Are you guys with me? So basically, section 4.3 and 4.2 were all about place value systems. Where you put the number changes what it's that many of. Cool? The most basic type of system, the system that makes sense, is one of the first ones to kind of occur to people, was an additive system. Meaning, if I want to represent 400, I put the symbol for 100 4 times. That is a very basic way to do it, which leads to a lot of unnecessary overcomplication, but it also makes writing like a number like 1,000,000 very easy. One little astonished person, there's 1,000,000, right? But the drawbacks overwhelm the advantages. So obviously, who am I referring to? Who has an additive system?
Egyptians.
Egyptians, cool. Who else? Make it an actual line. Romans. Right? Cool. And there were other people. So the book is only talking about certain civilizations. Part of the project I'm going to give you it's going to have you researching civilization that's not in our book. And there are a ton of them. And I've given you like a list on the handout that you can pick from if you want, or you can go off of there. Somebody brought up the game Myst. Any of you guys ever played Myst? The game, the computer game Myst? It's okay, you can admit to it. It's all right. It's a game. What the hell?
It's an older game.
It's an older game, I know. So maybe what's the more recent one? There's Raven. I used to play some of those. Oh, too bad for me. They're not like D&D kind of weirdness. Give me a break. We don't roll 40-sided die. This is an online computer game. It's not even online. It's just a computer game. It's pretty cool. But in that game, what really intrigues me, which is probably going to turn some of you guys off, I'm not going to play that game now, is they had a civilization that had a valid number system. It was the Denis, D''Ni. So you could even use fake, made-up civilization that somebody else has made up. You can look at their number systems. Because it better be kind of valid. It better be a certain type. It better have numerals for everything that they need numerals for, so forth. Cool? So if there's no questions about, so this is basically this one here is 4.3 and 4.2. This one is from 4.1. And the people that we still have to talk about in section 4.1 are the people that use a third type of system. And these are people that use what's called a multiplicative system. So what's kind of bad about the Egyptians? If they want to write the number 99, for example, how do I write that in Egyptian?
You have to write 9 tens and 9.
Yeah, 9 heel bones.
Yeah.
And then 9 staffs. I lost track. 4, 4. Okay, good. You guys with me? So that kind of sucks. It only took us, I had to write the number 9 twice to write the number 99, right? Whereas for Egyptians, they got to write 9 heel bones and 9 staffs. That takes a little while.
What does HA mean?
What does HA mean? Hindu Arabic. That's our numerals, are actually nothing that we made up. We're using some other civilization's numerals, Hindu Arabic. Right? We didn't, we didn't come up with the Declaration of Independence and then go, and we'll use these numerals. No, this is numerals from a long ass time ago that we just modified to be ours. Right? Okay, cool. Now, so what's kind of wrong with what's one way I can improve on that? And you can't use a place value system. That's ours. I want another way. What sucks about this is I've got 9 tens, but I have to write actually 9 symbols out. What would be so much better is if I had a symbol for 10 and a symbol for 9. And I could just write I got 9 tens. So it'd be sort of like writing 9 tens and 9 ones. Right? So sort of like ours, but not quite ours. Ours is all about where I put it. I put a 9 here, so it's the ones place. I put a 9 there, that's the tens place. This is more like putting a symbol for 9 and a symbol for 10. And then a symbol for 9 and a symbol for 1. So you can see why this is called a multiplicative system now, right? It's kind of improving on the Egyptians and the Romans, making it a little more concise. So multiplicative system. Let me make sure I'm going in the right order here. Cool. Page 185. Now these are definitely some symbols I'm not going to make you memorize. And they're not even symbols that are used today necessarily in everyday usage. These are ancient Chinese numerals. So you can see them on the bottom page 185. So it starts off kind of nice. It starts off almost like the Mayans in that they have the little wavy dude is 1, 2 little wavy dudes is 2, 3 pieces of bacon there. Right? And again, I mean no disrespect. Just listen. So like put your hands here, receive the bacon for the dryers in the bathrooms. 4 is one of my favorites. I've never had somebody agree with me with what this looks like. But what does 4 look like? Especially the terrible way I draw. So maybe a table.
A robot.
I think it looks like TV showing a very boring program of somebody's feet.
Yeah.
Right? So you're not going to have to memorize these numerals. It'd be kind of cool. The more you use them, the more they're going to stick in your head. Right? And I obviously mean no disrespect with, but it's interesting for us to interpret somebody else's symbols as to what they look like. Somebody else might be looking at our symbol there and think, what the hell is that all about? What does that symbol look like? Right? Trying to figure out what our symbols look like based on what they know. So here's how this works. Look at the very end here. The symbol for 10 is kind of nice. It's just a T, so that's useful. Symbol for 100, what does that look like to you guys?
But how does a 5 look like?
5 is a rocking chair.
Can you tell us?
I did. It's on page 185. Thankfully, I'm not going to subject you to my drawings too much. So on page 185 is all of the Chinese numerals. Yeah.
I used to live in Taiwan, and when we used to go shopping, they used to say 10. They used to do this all the time.
What's that? Oh, like that?
Yeah.
Okay,
number
cool.
10.
It's like a holdover from the
Yeah,
symbols
they're
they used to
still
use.
doing it. They're still
So that's
doing
10.
it.
That's a quick way to say 10.
They
I like
always
it.
do that when they speak.
So
they
2,
say
3,
10.
there's 10.
Yeah,
That's
they
awesome.
always do that. So I don't.
Okay.
What does that
So go to
sign?
10, 20, 30.
What does that sign mean?
This would be the next kind of one up. So notice this. I want you to realize, like the Egyptians, they didn't have a base 10 system. They had an additive system. It's not a base system. But then it wasn't kind of built on the number 10. A symbol for 10, a symbol for 100, a symbol for 1,000. It was still kind of revolving around the idea of tens. Same kind of thing here. Here's my single digits up through 9. That's in the book. Here's my symbol for 10. Here's my symbol for 100. And then here's my symbol for 1,000. Like that. So how do I put together one of these numbers? Well, this is really kind of nice. It's one step away from a base, a place system. If I wanted to say, for example, 35. If I want to say from Hindu Arabic, I want to say 35. So again, the Chinese, you probably know this, they go up and down, just like the Mayans did. But here's how theirs works. To say 35, I need 3 tens and 5 ones, really, right? So I need 3 tens, 3 tens, and then a 5. So they don't have a place. They can't just put a 3 there and know that it's in the tens place. They put a 3 in the 10, and we know that those pairs we multiply. So 3 tens is 30, plus 5 is 35. So that's a multiplicative system. Kind of cool. The funny thing is, in the edition before this, you see the symbol for 0? Very complex symbol. They really don't need a symbol for 0 in general. They could use it if they want to, but if I just had to write 4,005, I could just write 4 thousands and a symbol for 5. You could put a 0 in the middle just to make sure that people knew you didn't skip something. But you don't really need the symbol for 0 in this system, do you? Except if you want to tell somebody, I have none of those, and want a 0 symbol. But to make a general number, I don't need it. Yeah?
How do you know that they're a pair? Like, should you put them closer together, or like it's just you always
Everything's
pick the first
pairs
one?
until the end.
Okay.
Everything's pairs until the end.
So what if it was just? Oh, that makes sense. Okay.
Cool. So everything is pairs. So Romans are a little bit trickier. You got to look for the pairs. Because not everything has to be a pair. It could be single number, and then it's only a pair, with the one in front being smaller than the next one. Chinese is kind of nice. Everything's assumed to be a pair until you get to the single digits.
Okay.
Right? Yeah.
What about even numbers? Like, say you have 4,500
Okay, cool.
or something?
I like it. So let's write the number 4,500. So I need 4,500. That's all I need, right? 4 is whatever you think it is. I think it's the little TV show. 4,000. 4,000s. 5. The rocking chair, whatever you think that is.